All right, good day. Today we are graphing linear inequalities. And so we have done inequalities in one variable. Linear inequalities are just like well, they're not just like, they're similar to linear equations. So linear equations have the form y equals mx plus b. So you have two variables now because the y and the x are in the problem. So you will learn how to graph a linear inequality, learn how to graph linear inequalities, understand what a boundary line means when you refer to linear inequalities, and how to write the equation of a linear inequality given the graph. It should be how to write the inequality of a linear, because it's not an equation. Because equations have equal signs. All right, here we go. Solve and make a quick graph of each inequality. So we've done this before. And I'm only going to do two. You're going to do the other two because we've done these before. So we subtract 5 from both sides, subtract 5 from both sides, and we get 2z is less than negative 12. And then we divide by 2. Divide by 2. This is the inequality with one variable because we have one variable there. And we get z is less than negative 6. Quick graph. Quick small graph because I don't have a lot of room. All right, negative 6 is here. It's going to be a really quick graph because I taught y'all put numbers on the side, but since we don't have a lot of room, we'll just go here, open circle, because of the simple fact that it's less than and it's not equal to. Because it's not equal to, let me say that because I hate when y'all say it because it's less than. And then this is less than, would not look at here and say, oh, we shade this way. It works this time, but we read the inequality and less than is to the left. All right, and then I'll do the one underneath. Subtract 8 from both sides, subtract 8 from both sides. We get 2k is greater than or equal to 0. Divide by 2. Divide by 2. K is greater than or equal to 0. So, quick graph. 0 here. And we're saying k is greater than or equal to. So, equal to means solid circle. And then greater than goes to the right. So pause the video and do these two. Either way, they need to be done tomorrow. Since you've now done those two, hopefully, it says write an inequality for each graph. So we're going to write an inequality for this graph right here. So we're going to give any variable. We're going to say b is, what is this? So this is going to the right. So it's greater than, it's not equal to because the open circle, greater than 6. All right, y'all remember this. Do the next two on your own. So a linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol. The symbols of all inequalities are, this would be less than, this will be less than or equal to. Beautiful handwriting, I tell you. This will be greater than, and this will be greater than or equal to. All right, a solution of a linear inequality is any ordered pair that makes the inequality what? True. All right? All right, a linear inequality describes the region of the coordinate plane that has a boundary line. Every point in that region is a solution. Oh, it got cut off. Of the inequality. All right, this definition is very important. A linear inequality describes a region of the coordinate plane that has a boundary line. Every point in the region is a solution of the inequality. All right, so we're going to use this definition in a moment. All right, tell whether the order pairs is a solution of the inequality. Well, if it's the solution of the inequality, then it will make the statement true. So this is x, and this is y. And then when we plug in x and y, we're saying that 3 is less than 7 minus 1. Well, 7 minus 1 is 6. So is 3 less than 6? Yes. So this is a solution. Yes. It makes the inequality true. Do one more. This is x and this is y. So we're saying that 5 is greater than 3 times 4 plus 2. Well, 3 times 4 plus 2, that's 12 plus 2, that's 14. Is 5 greater than 14? No. This is not true. So this is not a solution. So this works. This does not. Do the next two on your own. Okay? Next two on your own. All right, so let's remember how to graph, because Latrell in fourth block kept asking me, how'd you graph, Mr. O'Neill? How'd you graph? How do you graph? I don't remember how to graph. I don't remember how to graph. Shame on you. All right, so the slope is 2, because the slope is next to x. And when we're graphing, we write slopes as fraction, because it's a rise over run. And our y-intercept is -1. So when we graph this, let's remember, when we graph this, we start at -1, and then we go up 2 to the right 1, up 2 to the right 1, and then mirror points. We can put as many points as we want. I'll just stop at 5. Line rises to the right because it's a positive slope, all that good stuff. Let's also remember that an inequality, a one variable inequality, A is greater than 2. So we go to 2, and since it's not equal to, we do not shade in or put a closed circle. It's an open circle, open dot, and greater than goes to the right. So we will shade right. Now, if I was teaching you today, I would ask you to use your mathematical imagination to combine what you believe a linear inequality would be, combining the y is greater than 2x minus 1, understanding that it's in slope-intercept form, and it has to, I guess, encompass or combine what we know about inequalities as well. Okay, I will do that and then ask you what your graph looks like, but I know some of y'all wouldn't even just move on to the lesson, whatever. So a linear inequality describes a region of the coordinate plane that has a boundary line. Every point in the region is a solution of the inequality. So you don't have to do that. If you would like to do that, there might be something special waiting for you. If you want to guess how would you encompass this definition with these two graphs and then graph this, might be something special waiting for you tomorrow, if you honestly do that. A linear inequality describes a region of the coordinate plane that has a boundary line. Every point in the region is a solution. So we're about to see this. So something to think about. What are the solutions of y equals 2x plus 1? Remember, a solution to a linear equation is an ordered pair on the line, because you input and you output. That's how we make the line. So let's remind you, at 0, when I input 0 as my x, my output is 1. That's where that 1 comes from. When I input 1 as my x, my output is 3. Okay, that is the reason why these are solutions, because we get true statements. Okay, when I input 2, my output is 1, 2, 3, 4, 5. So it says give 4 solutions to this equation and check them. I'm not going to spend too much time checking them because I think y'all should get the point. But at 0, 1 is a solution because 1 is equal to 2 times 0 plus 1. 1 is equal to 1. That is the reason why it's a solution. It makes the equation true. Input, get my output. Okay, another solution would be -1, -1. It's on the line, and we can see this because when we put in our input of negative 1 and my output, 2 times negative 1 plus 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. It makes the equation true. That's why it's a solution. Okay? I want you to do 2 more points. And then just write what are your conclusions. Okay? Why are these solutions? Why? Why are these a solution to this linear equation? Okay?